Hi, welcome back to another video. Think back to what we did in chapter 16. We said that in real life, our motion is almost impossible to be a linear function. Because again, if we take driving as an example, in real life, we never go at a constant speed all the time. Sometimes we slow down, sometimes we speed up, and sometimes we stop. So you see, our speed is varying. It's always changing. That's when we introduce the concept of average rate of change. And we said that even when your motion is a nonlinear, a curve, we can still measure the average speed, in other words, the gradient, between 2 points. But we need to keep in mind that the gradient of a nonlinear function also changes all the time. So different time intervals will have different gradients or different average speed. So we can only estimate the gradient in each interval. We then introduced instantaneous rate of change. And we said that instantaneous rate of change is the change at a point, okay, at that very moment. But we ended up using 2 points again in order to find the gradient. So although we chose points that are really close in the hope of, finding the accurate gradient, but we're still just estimating after all. It wasn't the accurate gradient. So we need a tool that can help us find the accurate gradient. And this tool is called calculus. Okay, lots of words. To start off, we'll be talking about limits in this video. Okay, so the tangent to a curve at a point. Consider this function. F of x is equal to x squared. So it's a quadratic function. The tangent to a curve at a point. Well, here we are talking about at one point. What does this remind you of? Instantaneous rate of change, right? So instantaneous rate of change measured the gradient at one point, and the line was called the tangent line. So let's say that if we take a random point on this graph, if I take point P, but instead of using a specific number, I'll use a letter. So we've seen this in algebra, we can use any letter to represent any number. So no big deal. Let's use A. So if the horizontal distance is A, okay, that means the x value for P is A. What about the y value? The corresponding y value is going to be f of a. So if you're subbing a into the equation, you have a squared. So the corresponding y value when x is a squared. Right, so we just found the coordinate for P. Well, after this, we know that we need another point that's very close to point P. Okay, maybe let's call it point Q. So we want point Q to be very close to point P, as close as possible. And clearly the x value for point Q is going to be greater than the x value for point P, because it's more to the right. So we're suggesting that the distance between point P and Q, the horizontal distance, is h, all right? So if the x value for P is a, then the x value for Q is simply a plus h. So h is the difference between the x values of these 2 points. So that means the x value for Q is going to be a plus h. What about the corresponding y value? So we're going to sub in x is equal to a plus h into this equation, and it's going to be a plus h, this whole thing squared. Okay, now be very careful. The output is going to be this whole thing, a plus h squared, because as an input, it's not a number anymore. It's not a specific number. We're putting in this expression as our x value. So that's why the output is not a specific number either, because we're using letters here. All right, so the output is going to be a plus h, the whole thing squared. All right, now do we know the 2 points? Yes. Let's use the formula y2 minus y1 over x2 minus x1 to find the gradient. All right, so gradient m is equal to y2 minus y1 over x2 minus x1. What's our y2? Actually, let me label this. So this is our y2, and this is y1, this is x2, and this is x1. So y2 is a plus h squared minus y1 is a squared over x2 is a plus h minus x1 is a. All right, now let's try to simplify this fraction by expanding the brackets. So for this perfect square, we have a squared plus 2ah plus h squared minus a squared over, this is a positive a and a negative a. Okay, they cancel each other out, and we only have h left. And for the numerator, a squared minus a squared, so that's gone. And we're left with 2ah plus h squared over h. So h is a common factor, so let's divide h. So this h will be gone, h divided by h is 1, and h squared divided by h will just be h. And we're left with 2a plus h. Remember we said we want the 2 points to be as close as possible. So ideally, we want the difference in the x values to be as close to 0 as possible. So when h is getting closer to 0, meaning that the 2 points are getting closer and closer. And then we say that the limit of 2a plus h as h approaches 0 is 2a. All right, so imagine if h is going to 0, then we're left with 2a only. So the tangent at point P is 2a. So here's an example. By first considering the gradient of the secant PQ, find the gradient of the tangent line to y is equal to x squared minus 2x at the point P with coordinates 3, 3. So the question labeled the points for us already. That's very nice. So we're essentially saying that we have the secant line that passes through point PQ, and the coordinate for P is 3, 3, and the coordinate for Q is 3 plus h. Okay, so remember h is the difference between the x values of these 2 coordinates. So if the horizontal value for P is 3, then the horizontal value for Q is 3 plus h. So let's find the gradient of PQ using our favorite formula. y2 minus y1 over x2 minus x1. This is our y2. This is our y1, that's x2, and that's x1. Y2 is 3 plus h squared minus 2 times 3 plus h, and y1 is 3 over x2 is 3 plus h minus x1 is 3. Okay, I'm going to write it here so we can have more space and expand the brackets. So 3 plus h squared is equal to 3 squared is 9 plus 2 times 3 times h is 6h plus h squared minus, so expanding the brackets, we're using distributive law. So 2 multiplies with everything that's in the brackets. Be very careful, maybe keep the bracket first, okay, because we have a negative sign in front. So 2 times 3 is 6 and 2 times h is 2h and minus 3. Okay, so plus 3 minus 3 cancels out nicely, and we only have h left. All right, let's now expand the bracket. 9 plus 6h plus h squared minus 6 minus 2h minus 3 over h. 9 minus 6 is 3. 3 minus 3 is 0, so that's gone. And 6h minus 2h, we're left with 4h plus h squared over h. All right, so if we cancel one h out of each term, that becomes, so this h is gone, becomes 1, that becomes 1, and h squared becomes h. So we're left with 4 plus h. And remember that we want h to be as close to 0 as possible. So as h approaches 0, the gradient of the tangent line at this point P is equal to 4. All right, find the gradient of the secant PQ, and hence find the derivative of x squared plus x. The secant line PQ passes through these 2 points, and we want to find the gradient first. We defined our function to be f of x is equal to x squared plus x. So when the input is x, the output is just going to be x squared plus x. But when the input is x plus h, the output is going to be x plus h squared plus x plus h. Okay, now let's find the gradient of PQ. I'll label this with different colors. So this expression, this whole thing is y2, and this is x2. This is y1, and x is x1. So the gradient is equal to y2 minus y1 over x2 minus x1. Okay, let's sub in the numbers. y2 is this part here, so x plus h squared plus x plus h, and y1 is going to be x squared plus x. Make sure this expression of y1 is in a bracket because we're taking this expression as a whole. X squared plus x, this whole thing represents our y2 value. So we need to treat them as a whole by putting a bracket around them. And since we have a negative sign in front of the brackets, When removing the brackets later on, the signs are going to change. Okay, x2 is x plus h, minus x1 is simply x. Okay, now let's expand the bracket. Okay, we have x squared plus 2xh plus h squared plus x plus h. Take away x squared minus x over plus x minus x, they cancel out nicely. We only have h left. All right, now let's try cancel things out. We have a plus x squared and a minus x squared, so that's gone. And we have a plus x minus x, that's gone. And we're left with 2xh plus h squared plus h over h. And to simplify, we can cancel h out of each term. And we end up with, sorry, this one is gone, that becomes 1, that becomes 1, h squared becomes h, and h becomes 1. So it's going to be 2x plus h plus 1 over 1, which is simply 2x plus h plus 1. Again, to make h as close to 0 as possible, so when h approaches 0, the gradient of pq approaches 2x plus 1. So we can say that the derivative of this equation is 2x plus 1. I hope you find this video helpful, and I'll see you in the next video. Bye!